Okay, so we are still doing quadratic formula. Quadratic. All right. Still quadratic formula, but we are moving on to different types of examples, and you guys are going to see what they have in common. So we're just going to jump right into it. So tell me, from what we learned yesterday, what should I do to this equation so that I'm ready to plug it into the quadratic formula? Okay, add the 8, subtract the 2x. So we're keeping the 3x squared positive just in case we were going to factor this problem. We prefer for our squared term to be positive. It makes it easier for us. Okay? And then when I write these terms down, what order should I write them in? 3x squared. Okay, and then positive 8. Okay. All right, so A is 3, B is negative 2, C is 8. And then what should I be writing for my quadratic formula? That's right. I was going to look up songs for you guys last night and I forgot. That's 4 times A times C. I do not have that guy's phone number. Sorry. I do not. I could probably look it up. It was a Chevron. They don't even have those in this state. They have them in Georgia, though. Yeah. All right, so we've got a 6 on the bottom. Minus minus makes a plus. Okay, so we've got to figure out what the discriminant is. We're going to make sure that we're not killing any baby otters because, you know, that's terrible. So negative 2 squared minus 4 times 3 times 8. What do we get? I'm not your calculator, man. What do we get?
Honestly, I forgot how to do it.
No, it does not say error because you didn't type in the square root. We are just getting the discriminant, so we are getting negative 92. Because we did not type in the square root. All right. We got negative 92. So what's different about this than yesterday? It's a negative number underneath the square root, right? Which technically we're not supposed to do. We're not supposed to square root negative numbers because we get an error on our calculator. You get an error on your calculator when you square root negative numbers. This is where you do the imaginary thing. So this is why I tell you guys to find the discriminant first. So this is why we take the stuff underneath the square root and we do not type the square root. Because if you type the square root with this, you won't be able to calculate it half the time, because you'll be getting a negative underneath the square root. So we type the discriminant, which is everything except for the square root. It's just the stuff underneath. When I type the stuff that's just underneath, I find that the discriminant is a negative 92. It's negative. That means that my answer is imaginary. That means I'm not going to get any real number answers. I'm getting fake number answers, which means that when I solve this equation, the answers are not real. That means if I was to graph this equation, there would be no x-intercepts. This graph would have no x-intercepts. So the entire graph, the entire U-shape, would be completely above the x-axis. It would not cross the x-axis at all. Okay, so what I'm going to do is I want to communicate to the person who looks at my paper, yes, I understand that these answers are fake. So what I'm going to do is I'm going to take this minus, I'm going to turn it into a plus, and I'm going to stick an I in front of the square root sign, and that just shows the person looking at my paper, yes, I understand these are fake answers. I'm not stupid. I know what I'm doing. So now we look at the 92, and if it's a perfect square, we keep going. If it's not a perfect square, we stop. Okay? Is 92 a perfect square? No, it is not. 81 is a perfect square. 100 is the next perfect square. So this is not a perfect square, which means we are done. I'm going to leave it right here, and I'm going to say x is 2. And if you wanted to write it as two separate answers, you could say your first answer is plus I root 92 over 6. You could do the plus minus if you wanted to write the answers together. Yeah, that would be fine. So if you wanted to write them separately, this is how you would write them separately. And you'd say those are your two answers and you're done. And the reason we're stopping, again, is because it is not a perfect square. Okay, so let's try another one like that, because I'm going to have to do some math to come up with one that is a perfect square. So let's do this one. And while you guys do this one, I will come up with one that's a perfect square for you. Mm-hmm. Mm-hmm. Because that's negative 8? All right, did you guys get it? Marvelous. Okay, let's try this one next. We're going to do this one together. So we're going to do x squared plus 34 equals negative 10x. So what should we do first? Add the 10x. Mm-hmm. So we have x squared plus 10x plus 34 equals 0. And then what should we do? ABC. Okay. And then what do we have? Negative b plus or minus. $34. And then all of this is divided by times 1. Okay. So this one is a little bit more interesting. Tell me why. You're close. Negative 36. So the discriminant is negative 36, which is a perfect square, which means we can keep going with this problem. No, we're going to do the I because it needs one, right? You're square rooting a negative, so it needs the I. But this one we don't have to stop because this problem can be simplified because it's got a perfect square. Mm-hmm. So, somebody tell me, what's the square root of 36? 6. So I'm going to say negative 10 plus or minus 6i divided by 2. Okay? And do these numbers... Do you guys need to go out in the hall so you can continue your conversation? Okay, because we know we're being rude. So we're going to stop. Don't nod at her, you're doing it too. All right. Are both of these numbers divisible by 2? Yes. So we're going to divide them both by 2, and what do we get? We get negative 5 plus or minus 3i. So our final answer would be x equals negative 5 plus 3i, negative 5 minus 3i. So how do we know that we should continue? Perfect square. Perfect square, you can make it look nicer, we do that. We don't do that if we have an imperfect, if we just have like a regular number. Not a perfect square, we leave it alone. Perfect square, we keep going. So I'm going to go ahead and write my two solutions over here. Negative 5 plus 3i, negative 5 minus 3i. Nope. We just want to know how to split them up if we needed to.
Why would you need to split them?
If somebody wanted to know what like one of the answers was or something. Because this doesn't have a plus minus. This does. So the negative 5 is true for both of them. The plus minus is only in front of the 3. Is what true for both of them? Because negative 10 is in the front. The plus minus is in the middle of the problem, so that's the only place where the sign would change. The negative 10 in the front, that stays the same. Okay. Yeah. Okay, let's try another one like that. Okay, so x squared equals 4x minus 5. Have you guys figured out what the discriminant is? Negative 4? Yeah, I'll give you a couple problems. Just like 2. How are we feeling about the quadratic formula in general? We can plug numbers in. We can get the discriminant. Say that again? Over here. Notice on number 3 I did not cancel the 6's. Anyone know why I didn't cancel the 6's? Because I couldn't do anything with the 72. So you got to cancel everything, yeah. Otherwise, you kill a puppy. So don't want to do that. It's not horrible for me because I don't do it. It's always my students who are killing things. I'm not. Then it's dead. Then you have to go tell its mom. I would be mad at you. Oh, I don't kill them. I don't do that. No. How do you accidentally walk up to something and like stab it with a knife? That's not an accident.
You might fall.
Oh, no. All right. So let me put the problems up for your homework. Since we're starting 15 minutes early, I'm going to put a couple extra problems because we're getting started before we go home. So 4 to 5.
Oh, you're gonna give us.
Of course, I'm giving you homework. That's how you get a grade in the class. Remember, we ditched Mr. Fulton's grades and we did these grades by doing a couple homework. Okay.
Now we tried, right?
Mhm. Yeah, but this is quadratic formula. You'd be getting them right anyway, right?
Sometimes I just be making silly mistakes.
That's fair.
Especially like when I'm at home and like I'm not in class anymore.
That's fair. Mhm.
If the number on the bottom, like you know where you do the 2A,
Mhm.
if that number is bigger than the one on the top, do you just leave it alone?
It doesn't matter if it's bigger or small. It just has to do with if it can be reduced or not. Like if it was like 5/10, like it's bigger, but it could be reduced to 1/2. You know.
4 and 16I, 32.
Say it again.
24 and 16I, 32.
Oh yeah, I would reduce that because they're all even. They can at least be reduced by 2, maybe reduced by 4, maybe reduced by 8. I can't remember what the numbers were.
Just wait close.
On the homework, is there supposed to be a problem with positive determinant?
Is it number 2? It's an accident, but let's go with it. You guys know we have a whole 5 minutes, so you don't need to actually be standing. Let's take a seat. Let's take a seat. A whole 5 minutes. A whole 5 minutes. Marvelous. So take a seat. Take a seat.